Hey friends, welcome to the YouTube channel All About Electronics. So in this question, we have been given the logic circuit based on the multiplexer and we have been asked to find the Boolean function which is realized by this logic circuit. So as you can see, this logic circuit is based on the multiplexer and the given multiplexer is the 4x1 multiplexer. So for this 4x1 multiplexer, we know that the output F can be given as this S1 bar dot S0 bar dot I0 plus S1 bar dot S0 dot I1 plus S1 dot S0 bar dot I2 plus S1 dot S0 dot I3. So this is the logical expression of this multiplexer. So here this S1 is equal to A while this S0 is equal to B. Moreover, here this I0 is equal to C and the complement of this C is given to the I2. That means this I2 is equal to C bar. Similarly, this I1 is equal to D while this I3 is equal to this C bar dot D bar. Because here if you see at the input side, then we have the two bubbles. That means the input to this I3 is equal to C bar dot D bar. So now let us put the values of this S1, S0 and all the inputs in this expression. That means now this function F is equal to A bar dot B bar dot C plus A bar dot B dot D plus A dot B bar dot C bar plus A dot B dot C bar dot D bar. So in this way we got the logical expression in terms of the variables A, B, C and D. So now let us expand this expression and let us find this logical expression in terms of the canonical SOP form. So we have already seen that how to expand this non-canonical SOP form expression into the canonical form. But the easiest way is to map this function in the K-map. And from the K-map we can easily identify that which minterms are present in this function. So first, let us map this function in the K-map. So the first term in this expression is equal to A bar dot B bar dot C. That means here both the variables A and B are 0 and the variable C is equal to 1. That means it will contain these two minterms because in this row the variable A and B are 0 while in these two columns the variable C is equal to 1. Similarly, if we map this A bar dot B dot D, then we will have these two terms because in this column the variable A is equal to 0 while the variable B is equal to 1 and in these two columns the value of the variable D is equal to 1. Likewise, this A dot B bar dot C bar corresponds to the minterm 8 and 9 because in this row if you see then the variable A is equal to 1 while the B is equal to 0 and in these two columns the value of the variable C is equal to 0. That means if we map this A dot B bar dot C bar in the K map, then we will have the two minterms that is 8 and 9. Likewise, this A dot B dot C bar dot D bar corresponds to the minterm 12. So in this way, we got all the minterms of this given function. So now, if we write all these minterms in the canonical SOP form, then this function F is equal to summation of variable 2, 3, 5, 7, 8, 9 and 12. So this is the Boolean function of the given logic circuit. And from this we can say that for the given question, this D is the correct answer. Alright, so now let us move to the next example. So in this example also, we have been given the multiplexer circuit and we have been given that the output of this multiplexer is the XOR of the variable C and D. So here to get this output, we have been asked to find the values of the inputs A0, A1, A2 and A3. So once again, here the given multiplexer is the 4x1 multiplexer and the earlier we have already seen the logic function of this 4x1 multiplexer. That means the output of this 4x1 multiplexer F is equal to S1 bar dot S0 bar dot A0 plus S1 bar dot S0 dot A1 plus S1 dot S0 bar dot A2 plus S1 dot S0 dot A3. So this is the Boolean function of this given multiplexer. So here this S1 is equal to C while the S0 is equal to D. And here we have been given that this output function F is equal to XOR of C and D, that is equal to C bar dot D plus C dot D bar. So first of all, let us put the values of this S1 and S0 in the first expression. So if we put the values of this S1 and S0, then the output function F can be given as the C bar dot D bar dot A0 plus C bar dot D dot A1 plus C dot D bar dot A2 plus C dot D dot A3. So here to get this output function F, we require only these two terms. That means here the value of the function A0 and A3 should be equal to 0. Moreover, here the value of A1 and A2 should be equal to 1. Because if the value of this A1 and A2 is 1, then we will get this expression. That means here the value of this A1 and A2 should be equal to 1. And with these values, if we see the output function, then that is equal to C bar dot D plus C dot D bar. So from this we can say that to get the output function F, that is C XOR D, the value of this A0 should be equal to 0, while the value of this A1 and A2 should be equal to 1. And similarly, the value of this A3 should be equal to 0. So with these input values, the output function F is equal to C XOR D. And from this we can say that for the given question, this C is the correct answer.